Assalamualaikum friends, this is Muhammad Inam and today I am going to talk about Riccati Differential Equation, which is first order nonlinear differential equation. It has variety of application in physics and engineering. I have already published some research work about Riccati's in Icomet 2019. So the contents of the video is couple of useful substitution which reduce Riccati into linear equations, few ways for finding non-solution, perturbation technique and comparison between results. So see the entire video, and if you like the video then subscribe my channel. Friends, let's start Riccati's differential equation and their substitution. The general form of this Riccati's is y prime plus p of x y plus q of x y squared equals to r of x, some function. This is the general form of Riccati's differential equation. And substitution number 1, y equals to y1 plus u. This substitution will reduce where y1 is non-solution. Keep in mind y1 is non-solution. Where this substitution will reduce Riccati's into Bernoulli's differential equation. Into Bernoulli's. And number 2, y equals to y1 plus 1 upon u. This substitution will reduce into linear differential equation. And the third one is y equals to 1 upon q of x times u into u prime. This substitution will transform Riccati into second order linear differential equation. So I'm going to show you one by one how these are transforming. So from number 1, y prime plus p of x y plus q of x y square equals to r of x, some function. If I am assuming that y equals to y1 plus u, then y prime equals to y1 prime plus u prime. I am substitute this thing here. So y1 prime plus u prime plus p y1 plus u plus q y1 plus u whole squared equals to r of x, some function r. Then u1 prime plus u prime plus py prime plus pu plus q y1 squared plus 2y1 times u plus u squared equals to r. This implies that y1 prime plus u prime plus p y1 plus pu plus q y1 squared plus 2 times y1 qu plus qu squared equals to r. If y1 is a particular solution, then this all terms will be 0. The remaining part will be u prime plus p plus 2y1 q u plus q u square equals to 0. Now this is Bernoulli's differential equation where degree is equals to 2. So we can use this for finding y, general solution. Now second substitution. One upon u, then the derivative of this thing is minus u derivative and u squared. I'm going to substitute this thing here. So what we have, y1 derivative minus u derivative over u squared plus p of p times y1 plus 1 upon u plus q y1 plus 1 upon u whole square equals to r of x. y1 derivative minus u derivative over u squared plus p y1 plus p upon u plus q y1 whole square. This square will be y1 square plus 2 y1 divided by u plus 1 upon u square. So multiplying q y1 square plus 2q y1 divided by u plus q over u squared equals to r of x. If y1 is a particular solution, then again these terms will be 0, this term also 0, this term will 0, and so we have remaining part minus u. I'm multiplying throughout u square, so pu plus 2q y1 u plus q, this term also is equals to q, and rechanging order, u prime minus p minus 2q y1 times u equals to q, and this is first order non-homogeneous linear differential equation. So we can also use this substitution as well. Now last substitution, y equals to z prime over q times z. Then y prime, by using quotient rule, say this is u and this is v, y prime will be u derivative v minus v derivative u divided by v square. U derivative means z double prime, of course, multiply by v means q z minus v derivative. V derivative is again by using multiplication rule, q prime z plus z prime q, multiply by u means z prime, divided by qz whole square means q square and z square. Now simplification will give us z double prime qz divided by q square z square minus q prime z prime divided by q square z square minus z prime square q divided by q square and z square. If I'm going to cut these things, remaining part will be y prime equals to z double prime divided by qz minus q prime z prime divided by q square z minus z prime square divided by q times z square. Now I've substitute this y prime into the equation. Z double prime over qz minus q prime z prime divided by q square z minus z prime whole square divided by q z square plus p times y. What is y? Y z prime divided by q z plus q into y square means z derivative over qz whole square equals to r, some function r. And now simplifying, q prime qz minus q prime z prime divided by q square z minus z prime whole square divided by qz square plus p z prime divided by qz plus z prime whole square divided by qz square equals to r. Now these two terms are cancelling out, and I am multiplying both sides by qz, then it will be z double prime minus q prime z prime dividing by q and plus p z prime minus r equals to 0. Then z double prime plus p minus q prime over q times z prime minus r times z. I multiply by qz, so here will be qz equals to 0. This is our required second order differential equation, which is homogeneous and linear also. So I have shown you three substitutions which will reduce your equations into linear, Bernoulli and second order differential equation, where p of x, q of x and r of x are constant functions, then we can find particular y1 easily by using this substitution y1 equals to k. This substitution will give us our y1 for further process. And case number 2, if this p of x, q of x equals to some function, a new function f of x, then we can easily solve our Riccati differential. If these all are same, then we can easily solve our Riccati equation by using this technique, dy over y squared plus y plus 1 equals to integration f of x dx. Then our Riccati differential equation can be easily solved by this technique. So friends, I have this one particular example and I will show this one by using particular substitution by one, and then second order, and then finally perturbation, the same problem, and we will compare the results of the solutions which we will get. So by substitution, y1 equals to ax square, and suppose this is my substitution for particular one, then what derivative 2ax, then 2ax plus 1 over x, ax square minus 1 over x cube, a square x power 4 equals to 2 times x, and this will be what we have now, 2ax plus ax minus a square x equals to 2x. Now I can cancel x from all sides. The remaining part equal 2a plus a minus a square plus 3a equals to 2. So from solving we get roots for this equation, and my y1 is x square, means a equals to 1. For further using this y1, I can solve this by using particular solution. I can transform my Riccati into linear, and I can get the result y equals to cx cube plus 2x square divided by cx plus 1. This is my solution using y equals to y1 plus u, this substitution. Now I can transform this equation using another substitution in second order, and we will see the solution what we get from that substitution. So the second order substitution will be, I can found by this result. Here this is my p, and this is my q, and this is my r. So I can transform z double prime plus p, means 1 over x minus, what is q prime? Q prime will be 3 over x power 4 and q minus 1 over x cube. Z prime minus r means 2 times x and q. What is q? Q is minus 1 over x cube, and z equals to 0. So this will go out, z double prime plus 1 over x, this minus minus plus, and this is 3 over x, z prime minus 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 plus, and this will be 2 over x square times z equals to 0. So further more simplification will have 4 over x z prime plus 2 over x square z equals to 0. Multiply whole equation by x square, we will have this equation, and this is Euler-Cauchy equation. We know the way to solve this one, and we will find the result in terms of y, z prime, q, z. This will give us result c1 x cube plus 2c2x square divided by c1x plus c2. Our y will be like this one. So if I'm comparing this y from my previous solution, I can easily say that c2 equals to 1. If c2 equals to 1, then this both solution means from the second order differential equation and from the first order differential equation we get the same result. Now last technique is perturbation, and I am going to apply the perturbation technique here for analysis comparison between the solutions and results. So finally guys, I am using perturbation technique, and if you don't know about perturbation technique, then you can learn here what is perturbation technique. So using perturbation technique, y of x equals to y naught plus epsilon y1 plus up to so on, and I am order of epsilon square, and I am truncate these terms because I don't want to compute more result for the sake of time. So here we can add epsilon from these terms, those terms which are non-linearity in the equation. So here the non-linearity occurs from this term, so I can add epsilon here, and I have one initial condition, and keep in mind epsilon, the domain of epsilon is just this one. So how can I use this technique? Then y derivative will be y naught derivative plus epsilon y1 derivative plus 1 over x, what is y? My y is y naught plus epsilon y1 minus 1 over x cube epsilon square, epsilon times y square. What is this? Y naught plus epsilon y1 whole square equals to 2 times x. So y naught epsilon plus epsilon y1 derivative plus y naught over x plus epsilon y1 over x minus 1 over x cube, this epsilon, the whole square will be y naught square plus 2 times y1 epsilon, 2 times epsilon y1 y naught plus epsilon square y1 square equals to 2 times x. So here we now we can simplify, plus epsilon y1 derivative plus y naught over x plus epsilon y1 over x minus epsilon y naught square divided by x cube plus 2 minus 2 epsilon square y1 y naught over x cube minus epsilon cube y1 square over x cube equals to 2 times x. So now we need epsilon of order 0 and epsilon of order 1 and epsilon of order square corresponding equations. So first I remove. So from these results I can see that here epsilon equals to 0, here epsilon equals to 0, and last one epsilon equals to 0. So epsilon 0 equation will be y naught of derivative plus y naught of over x and equals to 2x. This is for epsilon order 0, and for epsilon order 1 equation will be here epsilon equals to 1, epsilon y1 derivative plus epsilon y1 over x minus epsilon y naught square over x cube equals to 0, and ordered equation and epsilon square 2 epsilon square y1 y naught over x cube minus epsilon square y1 square over x cube equals to 0. So I have three equations, and you can see that this is linear, this is linear. After y1 we will have y naught, y naught, we will have this result. So this will again linear, and this is also linear. So when we sum up these all results, so we have results. I know you can solve these 3 differential equations because they are linear. For the sake of time, I'm going to show you the results. After solving this y naught, this epsilon order 0 equation and epsilon order 1 equation, we will have our y of x is equals to y naught plus epsilon of y1. So this is my epsilon naught, and this is my complete y1 from epsilon. So I found this result for this Riccati differential equation using perturbation technique. Now I can show you by graphs what kind of result we have. That is my comparison. So friends, so this is what my research work. So if you have any difficulty, you can ask in comments. I can try to resolve your issue. So if you like the video, then share it with your friends and support me. Thank you.